Okay, so first up, like uh, what what we're gonna do here is that we try to find the max value. So I mean we always like start from the bottom. So I mean here it has no children, so like the max value will be 4 over here, and I mean over here is that like whatever you see over here is basically you're following by the operation z, where you get the max value and put it up as a form of memory. That's why you put it on the side over here. So same thing, operation z, you see a 5 here, obviously the max value here is 5. Cool, right? Now you then proceed up, that you're gonna come to here. So I mean here um, you actually will want to actually do this new operation, which is operation y. Operation y is having this formula, where like this formula is involves that you do get the um, the max value of the left or the right, and then you plus your current value, which is 3 for this case. So for this case, it's so much of like this 3, and the max value of the left right is obviously the 5, so you plus a 5, and therefore you get the 8 over here. And this formula, it's formula G, like this formula G is basically calculating the max for if say there's like no split. So the thing about like each node, like we can have like a special case scenario. So a special case scenario where that your character can cast a spell of split. So operation W is casting the spell split. So if you are actually am able to actually perform the split, you are, and technically what your formula will be different. Like you're gonna be formula H, right? Formula H, it's your current. You're gonna plus both the left and the right. And so obviously when you do this, you're gonna plus 3 your current, you're gonna plus your left, you're gonna plus your right, and overall what you're gonna get, I mean the moment you cast splits, you're eventually using the formula H for this case, and this H for this case is gonna give you like a special value, which is 12. And each time you calculate each of like the results, obviously you're gonna update the 4, you're gonna update the 5, and then eventually you see that wow, this value, each time the value it gets larger, you're gonna update it. Therefore you put in a 12 over here, whereby we cast a special operation of like W, and obviously you can cast like this operation W as long as like you see a chance for it to cast split. So any item that is like sort of a subroot or the main root or the subroot, as long as it is a root where there's like 2 arrows, is a root, and you can cast a split. So for this item, you can cast a speed. This item, you can cast a speed, which we eventually will get into. So yeah, I mean, if this guy has like a children, yeah, it can cast the speed as well. If this guy has double children, it also can cast. So, but when you cast a formula H, there's one thing that you do need to take note is that you won't be recording this value. It won't be part of like the memory to be returned to pop back up. You don't need to pop the memory back up. But for formula G is that you do see that like that's this maximum memory, and you do usually have to actually pop it up. You got to pop the memory up. So each time that we get like this value, the max of like the memory, we pop it back up. And for this case, it's usually the formula G. We pop this back up, hit, come to here, and I mean, whatever this guy is asking, it's really comes down to two items: the normal case scenario, because when you reach a root, you got the chance to actually cast normal or special. But for items like this, it has no opportunity to cast spell of this special node. It's because it doesn't have children. But for this item, which we actually enter is a root, therefore you can cast this special. So you're gonna ask the special one more time, is that if I were to cast the split spell which is formula H, and for this case the current is 1, whilst the max of the left side is a 2, we insert the 2, whilst the max of the right side, and as you can see, is this 8 over here. You don't need to go all the way deep, you just need to go to your neighbors, because your neighbors has already calculated recursively from the start, and so you don't need to go all the way here. You can just go to the neighbor of your item, and it will do all the work, because over here it has like formed the max memory throughout. So your max of your right side, it's 8, right? So obviously the total is like 11. You don't update your results. Cool. But you go back to the normal case. Obviously you want to have yourself to actually calculate the formula G, which is the Y operation. Your current is your 1s, you plus your max the left or right. Obviously 8 is like higher, plus the 8, you get a 9 over here, and doesn't update the result because no matter, because 12 is bigger than everything else. And with that, you solve here, you solve here, you solve here, you solve here. Obviously you need to solve here. Yes, it's just like a simple base case which is operating like this operation normal, and for this it's just a 2 by itself, right? So it's just gonna update the 2. So like with that said, obviously you're gonna like keep on proceeding. I mean, it's basically we run through every single thing already, and if you were to see, it's a very it's happening over and over again. Is that you have these multiple operations that's actually happening, and not just multiple operations for this part. We are talking about having this special case scenario. We're talking about having like this normal case scenario, and for each case you're gonna operate its own operation. And with that, when you talk about having a special and a normal, we're talking about like smart maneuver, maneuver map. And when we talk about all this, we are obviously casting bringing out the character of like the DFS system, which falls under the tree, and that's the character that we are using. And I think it's a lot to do with like the rule book from the very start. Is that whatever it's trying to ask over here is that they want you to eventually find the max path. And when you talk about a lot to do with max path, is to do a lot with having said that you need some form of like max memory operations. So set for like every single node, and even you talk a lot to do with like neighboring node, that maybe say for like this item, you don't necessarily yeah, sure, you're getting the deeper root of like this item, but what you're doing here is you're just getting the neighbors. And how are you just be able to afford to just use your neighbors when you need like the information from here? The thing is this, that we use the operations of memory, the operation Z, that because we a lot of times we use the max memory pop. We pop this among these 5 and 4, we pop back the 5. We are just constantly sending back, we are popping the max value into this place, so that the next time this guy is asking for his neighbors, it's already a consolidated item, and what this guy cares about is just the consolidated item. And if you are able to do that, I don't need to do make the trouble to go all the way deep, and I can just use my neighboring item by using the whatever's installed for us with using the max memory pop, and we are then able to actually calculate 1 plus 8 and equals to 9. It's a very smart system, if you were to ask me, as opposed to going through 1, 3, and 5. You are just going the 1 and the 3, and you are actually able to calculate out the formula. I think to me that's like the special facade for using these spells. I mean, obviously, you then will always use the brute force to actually fight the main character of the tree. And for this case, I feel like just now whatever we argue is like basically Operation F. Operation F is that you plus 1, plus 3, plus 5. And each time you want to count a combination, you got to go all the way deep. and then maybe say for one combination you got to calculate here, and then you also got to calculate here. So if you were to see, there's like this extra step that you're calculating, but for operation O, where it's using the tree, it uses neighbors. You just calculate like this item and this item, and that's all, because it has already popped back up the max memory from either of these items over to here, and you just 1 plus 8 and you're done. But operation F, you got to calculate 1 3 5 1 3 4, and you will see there's this extra move that you're doing, and you're counting the extra node as well. But operation O is this guy and this guy. It's just this guy and the neighbor, and that's it. And with that, I use the operation O to actually argue back against the brute force. And I think with that, um, yeah, everything comes to an end.